Welcome to the course on machine learning. In this video, we will see how to find out the Gini index and how to measure the overall impurity of a particular dataset after selecting an attribute for a split. So in the first step, we will find the impurity of the total dataset by with this particular formula, and then after the partition or the split, we will find out the impurity of each partition. Let's say the dataset D is divided into two parts, D1 and D2. Then we will find out the Gini index of that particular split, and then we will find out the reduction in the impurity by subtracting the Gini index of that particular split subtracted from the Gini index of the overall dataset. And like that, we will select the attribute which will give us the minimum impurity. Let us consider this example. In the whole dataset, there are total 8 bubbles, let's say 8 O, and 10 crosses. And let us say we have a particular split in this dataset. So let us consider this red line as the split. So this split gives us two partitions. In one partition, so after the partition, let's give this partition as name A, and after the partition we will have 10 crosses out of 13. So let's say it's a D1, so number of crosses are 10 out of 13 and number of O's are 3 out of 13. And let's say the another partition as D2, and the number of crosses are 0 out of 5 and number of dots are 5 out of 5. Now we will calculate the Gini index of the dataset. So Gini index of the dataset, let's say D, is nothing but 1 minus 10 by 18 square plus 8 by 18 square. Sorry. So it is nothing but 1 minus 0.30 plus 8 by 18 square gives us something around 0.19 or 20, yeah, is equal to, so 1 minus 50, it's around 1.50. And now we will calculate the Gini index after the split. So Gini of the dataset D1 is nothing but 1 minus 10 by 13 square and plus 3 by 13 square. So 10 by 13 square plus 3 by 13 square. Which is 1 minus 0.59 plus 0.053. It's around 1 minus 64, and the total Gini index of D1 is 0.35. And now let us calculate the Gini index of the partition D2, which is 1 minus 0 by 5 square, which is nothing but 0, and 5 by 5, that is 1 square. So 1 minus 1 is 0. And now let us calculate the total impurity after the partition. So after the split at A, the total partition at the address at D, so it is the 13 by 18 into 0.356, that is the proportion of the number of samples on one partition, and other partition has 5 samples, so 5 by 18 into the index, that is 0. So it gives us 0.72 into 0.356 plus 0 is equal to 0.257. And then let us calculate the change in the Gini index or change in the impurity measure. So Gini due to split A is Gini of the D minus the Gini index at A. It is, so you can see that it is 0.5 is the Gini index of the total data set. So 0.5 minus 0.257, which comes around 0.243 actually. Change in Gini with split A is 0.243. Please correct it. Thank you for watching this video. I hope you have understood this concept. Please write your feedback to me.